All right, 1/4 divide, oh, not 1/4, 1 4/10 divided by 2/10. So how do we start it out? 1 whole and 4/10. Now we're dividing them into groups of what? 2/10. So here's one group of 2/10. Do we have another? 2 groups of 2/10. 3 groups of 2/10. 4, 5, 6, and 7. So we were able to make 7 groups of 2/10. So 1 4/10 divided by 2/10 is 7. We made 7 groups. Okay? All right, model and problem 4/6 times 1/3. What are we going to do first? Cut it into 6. Yep. And how many of those are we going to color in? 4. Then what do? Cut it into thirds. Good. And how many of those do I color in? 1. Okay, and our answer is where we have both colors. Okay, what's our hole split into now? Cut into 18, right? Because we've got a 6 by 3 array. Okay, and how many do we have that are colored both colors? 4. Now tell me what's the problem with that answer. They're both even. So they're not in simplest form. So what can we divide by? 2. So 4 divided by 2 is? And 18 divided by 2 is? 9. Okay? Can 9 be divided by 2? And 2 is prime. So 4/6 times 1/3 equals 2/9. Okay, now I checked this. I checked the answer key, and I was doing it correct at the first. It wants us to find out what the volume of the whole cube, and we have to solve that. So it's not just finding out this and this, it's finding out the whole volume. Okay, so what's our formula for volume? Good. What's our length? What's our width? What's our height? So 5 times 2 times 3. 5 times 2 is pretty easy to do. 10 times 3 is 30. Okay, draw a parallelogram with there's something over there. All right angles. What's a parallelogram? Nick. All the sides are parallel. What are right angles? Okay, 90-degree turns, L, corners, right? So what would be a parallelogram with all right angles? A square. Anything else? A rectangle would work too, right? Good. Hold on one sec. If we're going to multiply by 10, is our number going to get smaller or larger? Larger. So we've got a decimal there. So which way is our decimal going to go to get larger? Oh, so if I go from 83 to 0.7 and I turn it to the left, I've now got 8.37. Is that larger? Nope, so it's going to go to the right. So we times 8 times, and we annex how many zeros? Oh, nope, we moved the decimal, so 0. There, decimal's there. How many times are we going to move the decimal? Twice, 1, 2. What do we put in that space? A 0. 3 times, 1, 2, 3. 1, 2, 3. Okay, now we're multiplying by a decimal. And it's just like when we find out what 80% is. So what do we do? How many numbers are behind the 0? 1. And then what? So is it, remember when we find out what 80% of, we move our decimal to the left or to the right? Okay, so here we go. Let's do 11 times 0.8. 8, 8. And there's one number behind the decimal. Which way did we move it? To the left. So which way do you think we move this decimal? To the left. Good. How many times to the left? Twice. And how many times to the left? 3 times. Good. Yes, you can. You're welcome. All right. We are getting near the end of, we're right in the middle of fractions, so we're getting into the point where we're going to finish up fractions and then we're going to do decimals, and then by that time you should be able to do this all by yourself. It's hopefully getting much easier than it was at the first of the year, right? All right. I need you to open up to page 181. See if that will. Hey, who'd like to read our I can statement really loud? Thank you. Okay, so I can find a fractional part of a group. And we have done this before. Let me see if I can find an example of where we've done this. We might be too far. Oh, right here. 5/6 of 24. This is exactly what we're doing today. We're finding a fractional part of a number. Okay? How many of you feel pretty comfortable with what we do here? Okay, we will work on that. All right, let's see. We're going to start with our Math on the Spot video today.
You know, multiplying fractions is really an interesting thing to think about, and in fact, it's really useful too. And so it's important to really put our stamp on our understanding of multiplication, not just of whole numbers, but actually stamp our understanding of, in fact, multiplication by fractions. In fact, this reminds me of a really cool story involving stamps. Let's check it out. Now, Zach, Terry, and Paco combined the foreign stamps from their collections for a stamp show. Out of their collections, 4/7 of Zach's stamps, 3/4 of Terry's stamps, and 3/11 of Paco's stamps were from foreign countries. Here's our challenge. How many stamps were there in their display? Okay, so to find out how many stamps there were on display, we need to use this little table, which tells us the total number of stamps that each of these three young collectors have. So Zach has a stamp collection of 28 stamps, Terry 16, and Paco 22. And now we have the different fractions of these that are in fact foreign, and we have to figure them out. So for example, with Zach's collection, we know that 4/7 in fact are foreign stamps. So how do we find 4/7 of 28? Well, in math, when I hear of, that's a cue that means it's multiplication. Now, we've already seen that when we see and, like 3 and 5, that means addition, 3 plus 5. If I see 4/7 of 28, that means multiplication. So what we have to figure out is 4/7 of, which means times 28. Now, how do we figure out what 4/7 times 28 is, or what 4/7 of 28 is? Well, one thing we can do is we can actually model the number 28. We can model it by trying to create 7 rows. 7 rows to create 28. Well, then how many columns would we have? Well, in fact, if you think about it, it's not too hard to see that in fact we're going to need 4 columns, because 4 times 7 is 28. So we see 1, 2, 3, 4, 5, 6, 7. So there we have the 7 rows. And notice that we have 1, 2, 3, 4 of them. And so we know that 7 times 4 is 28. So this is a model for 28. But it's a nice model that's actually in sympathy, in a way, with the denominator 7, because now we have 7, we've partitioned it into 7. And how many of the 7 do we want? We want 4 of them. So the 4/7 of 28, we represent 28 in terms of rows of 7, and then we just take that part that we want, which in this case is 4. So in this case, I'll take group 4 of these. And when I lasso that in, that will tell me what the answer is. Well, how many are there? Well, let's see. There's 1, 2, 3, 4, and 1, 2, 3, 4. So it's 4 times 4, and if we actually multiply 4 times 4, we know that we get 16. So this actually equals 16. And that's a way of modeling to multiplying by a fraction. 4/7 of 28 is 16, or 4/7 times 28 equals 16. Great. Now, what about Terry? Well, Terry has 16 stamps, and we're told that 3/4 of them are foreign. So now we have to figure out 3/4 of 16. So now we're thinking about 3/4 of, that means times 16. So how do we model that? Well, the way we model that is we want to write 16 in terms of 4. So we want to have 4 rows and build 16. Well, to do that, what we would do, put it way up here, is we have 4 columns. So 4, 1, 2, 3, 4, by 4, 1, 2, 3, 4. 4 by 4 means I have 16 represented here in terms of 4. And how many do we want? Well, we want 3 of those. So we're going to select 3 from the groups of 4. So we want 3 of these groups. And so that red models, in fact, what 3/4 of 16 is, or what 3/4 times 16 equals. And what do we see it equals? Well, we can actually count all those x's, or we can just think about it as 4 times 3. 4 times 3 is 12. So we see that this represents 12. And then finally, what about Paco? Well, Paco has 22 stamps, and we're told that 3/11 of 22, in fact, are foreign. So we have to figure out 3/11, which is basically saying, what is 3/11 times 22? And how do we figure that out? Well, here's a chance for us to explore, because we want to write 22 now in rows that have 11 rows. So we want to have 11 rows here. So what do we see? Well, check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then how many columns would I need to make 22? It would have to be 2, because we know that 2 times 11 is 22. Great. And how many do we want to select? What's the part that we want? We want 3 11s. So we're going to lasso 3 of those rows. And if we lasso 3 of those rows, the amount we've lassoed represents this answer. And we can see that's easily seen to be 6. 3 times 2. So what is 3/11ths of 22? What is 3/11ths times 22? We now see it equals 6. Great. So Zach contributed 16 foreign stamps. Terry contributed 12 foreign stamps, and Paco contributed six foreign stamps. And so how many all together? Well, we just have to add 16 and 12 and 6. And when you add those up, of course, that's not so easy. That's not so hard to do. In fact, I did it for us. In fact, and we see the answer is 34. So how many stamps were in their display? The answer is the sum of these numbers, which is 34. Interesting that we now see, in fact, how we can use this model to actually figure out how to make meaning of multiplication of fractions. We've added fractions, we've subtracted fractions, and now we're seeing, in fact, that we can even multiply with fractions. And more importantly, it allows us to build insights into anything from understanding distances to figuring out different facts about nature to actually checking out stamps. In fact, I collect stamps too. And in fact, you want to see part of my stamp collection? I'm very proud of it. It's a very mathy stamp collection. I don't know if you can see it or not, but I love these stamps. Isn't that great? Isn't that wonderful stamp? I just want to look at the back of it and put on an envelope. I know I do. Have fun thinking about math, and I'll see you soon.
All right. Okay, so just a little, trying to turn this flat around so it can hear me better. Okay. So just a little bit of an example, right? Okay, we've done this before in our daily math test. So let's look at page 181. Aisha writes a children's story about quartets of cat musicians. What does quartet mean? Three? Quarters. Yeah, quarters. Okay, there's that root word quart or quad. What does quad mean? Four. So a quartet would have what? Four singers. Good. And two quartets play the cello. How many cats in two quartets play the cello? Okay, so if we have two quartets, how many do we have? How many cats do we have? 8. Okay, so one quartet equals what? 4. If we had in two quartets, we would have 8, right? Okay, so in two quartets, we have 8 cats. Now it says, in her story, 1/4 of the cats play the cello. How many cats in two quartets play the cello? So what do we need to solve? How many cats play the cello? But we only know that 1/4 of them play the cello. 1/4 of what? 8. Of 8, because it's the two quartets, right? So 1/4 of 8. Now, what did we say this word was? Multiplication. It is multiplication. Okay? So we are solving 1/4 times 8. Now let's do this. 8. Okay? Now, it said in our objective today that we want to use models. Okay? So we need to look at our numbers and we are going to come up with an array. You learned lots about arrays in 4th grade, right? Okay? So we need an array that has a total of 8, but it also has either rows or columns of 4. So what array could we draw that has a total of 8, but is in groups of 4? You can have 2 rows of 4. He says you can have 2 rows of 4. That one works, yes. What other way could we have? 1 row of 16. Nope, it's got to have 8 and 4. Total of 8, and it has to have 4 in there. 4 rows of 2? Yes, 4 rows of 2. So we could do either of those models, either of those arrays. Which one would we like to do? 4 rows of 2? Okay. So that's going to look like this. There's 1 row of 2, 2 rows of 2, 3 rows of 2, 4 rows of 2. Draw in your book. All right. So we've got our array. Now, I always like to put it so it looks like a rectangle. So I always like to put a rectangle around it, okay? Is there a way that we can now cut this into fourths? Is there a way for us to cut it into fourths? Okay? Someone tell me how. Yes. Okay, so right there, we're just going to cut along our rows, right? Now we have 4 pieces, right? Here's 1 fourth, here's 2 fourths, 3 fourths, 4 fourths, right? We want to know what 1/4 of 8 is. So how many am I going to shade in? 1/4, right? And this is 1/4, right? Does everybody understand and see where I've got my answer so far? Okay, so now we need to figure out what is 1/4 of 8. Well, how many do we have in 1/4? 2. So 1/4 of 8 equals 2. Okay, do you have it written down? So, how many cats, how many cellos are played in 2 quartets? 2 cellos. Okay, flip the page. After their concert, the cat quartet invites their friends to a party. Of the total number of cats shown, where are the cats shown? To the side, right? You can see them. 1/6 of the cats have striped tails. How many cats have striped tails? Okay, so first off, how many cats do we have? 12 cats. And it said 1/6 have striped tails, right? Okay. So we need to find out how many cats have striped tails. What are we trying to find out? Ooh, he knows exactly what's going on. Let's get some others. What do you think? What are we finding out? Someone from this area in this classroom. What do we need to find out? We got to find out what 1/6 of the 12 cats has striped tails. Good. What does it tell us when we see this word of? Multiplication. So we're doing 1/6. Whoops. 1/6 times 12. Okay, we need to come up with an array that has a total of 12, but either our columns or our rows are in 6. Manuel. 2 rows of 6. That works. 6 rows of 2. 6 rows of 2. Oops. That works. Which one do we want to do? That's going to take them more time. 2 rows of 6 could be pretty easy, right? Okay, so if I have 2 rows of 6, how many across am I going to have? 6. 1, 2, 3, 4, 5, 6. And I have to have 2 rows of them. Okay? Does everybody see where I got that from? We're just making arrays with these numbers involved, 6 and 12. Okay, now we want to make it a rectangle. So I'm going to put a square around it to make it a rectangle. Now my next question is how can I cut those so I have 6 pieces? How can I cut it so I have pieces that are in 6? Yes. Okay, good. 1, 2, 3, 4, 5, 6. Good. Now, how much of this array do I need to shade in? 1/6, right? So I need to shade in 1/6. So 1/6 of 12 equals what?
2.
Equals 2. Nope, I have only 2 that are shaded in. 1/6 of 12 equals 2. Okay? All right, let's look at number 2. 4 more cats join the party. Of the cats shown, 3/4 have solid colored tails. How many cats have solid colored tails? Okay, so how many cats do we have? 16 because 4 more joined, right? Okay, and we need to find out the colored tails. Solid colored. Which 3/4 of those 16 have solid colors. Okay, so what are we solving? Yes. Yes. 3/4 of 16. Well, this word tells us what to do. Multiply. Okay, so we need to come up with an array that has a total of 16, but it also either has 4 columns of 4 or rows of 4. What array could we have? Yes. 4 rows of, we want a total 16. 4 rows of 4. Can we do it for any other way? No, because it's got to be 4 times 4, right? Okay, so 4 rows of 4. 1, 2, 3, 4. There's 1 row of 4. 2 rows of 4. 3 rows of 4. 4 rows of 4. Okay, what do I want to do? I want to make it into a rectangle, right? And this actually is a what?
Square.
Square. Good. Okay, how can I cut my square to give me 4 pieces? Okay, I could go down. Could I go across too? I could, right? But I could go down too. Yep, that still would give me 4 pieces too. Okay? All right. Of that, how much do I want? Of the 16, how much do I want to shade in? 3/4. Here's 1/4. Here's 2/4. Here's 3/4. Okay? So 3/4 of 16, how many of those cats have a solid colored 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3/4 times 16 equals what? 12. Whoa, my 2 got a little bit wavy. Good. How many by a thumbs up are you understanding this concept? By a thumbs up. Okay, got a couple still not understanding, so we'll do about one or two more, okay? Okay, number 1, on check your understanding. I do that every time. At 9 o'clock, 5/8 of the 16 cats at a party go home. How many cats go home at 9 o'clock? Draw a visual model to find the answer. Okay, what do we need to find out? What is 5? It's not who's left. It's how many go home. So what are we going to find out? Say that again. 5/8 of 16. Okay. What do we need to do? And it said draw a model. Okay. So we've got, what did this word mean? Multiply. Okay. And we need to draw an array that has a total of 16 and has either your rows or your columns of 8. What would that look like? Yes. 2 rows of 8. Or 8 rows of 2. Good. Okay. I want you to decide which one you're going to do. Go. Hey, did you draw one of those arrays? Yes. Okay, what's the next step that I need to do? Put it back. Yep, make it into a rectangle. Okay? All right, I need those of you that did this array. How are you going to cut it into 8s to make them 8 equal pieces? Yes, down here. Those of you that did it this way, how are you going to make it 8s? Go across. Good. Okay, so now we've taken our 16 and we've cut it into pieces of 8s, into equal pieces of 8s. Now, how much of this 16 do we need to show again? 5 of them, because it's 5 8s. 1 8, 2 8, 3 8, 4 8, 5 8. Same with this one. 1 8, 2 8, 3 8, 4 8, 5 8. Okay, now what is 5/8 of 16? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it equals, I'll do it right here. 5/8 times 16 equals 10. Okay? Pretty easy? All right, let's do a check off real quick. Oh, no, it's time. Okay? Really quick. Turn to number 3 on page 184 on your own. It says, set by the carton of eggs, find the number of eggs in each fraction of the total. Okay? So, if you get a question like that on your assignment, has the total changed? No. What is our total? 18. Our total is 18. Right? All you're doing is now you're finding what 2/3 of 18 is. The next one you're finding out what 5/6 of 18 is. The next one you're finding out what 1/9 of 18 is. Does that make sense? Okay, you're just finding out the fractional part of 18 for the whole thing. Okay? All right, fist to 5 on how you feel about this lesson. Awesome. Okay, I have all 4s and 5s. So what we're going to do is get into math groups. Okay? The last group we'll figure out where you're going. We might have to just divvy you up or put you in one group at the end. Okay? All right, your assignment is 8.1. Front and back. It should not take you longer than the 30 minutes that you'll have to work on it today. Okay?